Dear colleagues, dear guests, it is my great pleasure to welcome you to today's public lecture given by Martin Enserink, our current Nature Marsilius visiting professor for science communication. Martin Enserink is a Dutch science journalist and deputy news editor at Science. Dear Mr. Enserink, a very special welcome to you. As a science journalist, you have a front row seat when it comes to current exciting discoveries by researchers. With their articles, researchers can inform, inspire, educate, and entertain the readership. At the same time, however, there is also a societal need for science journalists to report critically and independently on the darker sides of the science business, such as negligent research practice, fraud, plagiarism, or inappropriate behavior towards colleagues. Exposing such shortcomings and errors can contribute to regaining lost confidence in science. That's exactly the message that you underline as the current holder of the Nature Marsilius Visiting Professorship for Science Communication. We therefore look forward very much to your talk, which is entitled Cheerleaders, Guides, or Watchdogs, the Importance of Critical Science Journalism. The Nature Marsilius Visiting Professorship for Science Communication is a joint initiative by Holtzbrinck Berlin, the Klaus Tschira Foundation, and Heidelberg University. These three partners have joined forces to promote excellence in science communication and increase its visibility in the scientific community and among a broader audience. For Holtzbrinck Berlin, I would like to welcome the senior project leader, Anthony Andrews, and for the Klaus Tschira Foundation, the managing director, Rafael. Thank you very much for joining us tonight. The Marsilius Visiting Professorship enables us to invite outstanding communicators and journalists to Heidelberg University, who in turn can meet with our researchers and students to give lectures and to hold classes on topics ranging from scientific writing to media skills. At the same time, the visiting professors are expected to spark a broad discussion on new forms of exchange between academia and the public and about critical issues such as scientific fraud. Previous holders of the visiting professorship include, amongst others, Ionica Smith, Mighty Nguyen Kim, and Michele Catanzaro. Since science communication is crucial for all disciplines and the interdisciplinary dialogue, this visiting professorship is hosted by the Marsilius Kolleg, Heidelberg University's Interdisciplinary Center for Advanced Studies. Thanks to our Marsilius Kolleg directors, currently Professor Nüssel and Professor Butros, and our managing director, Mr. Just, very warm welcome to the three of you. The Marsilius Kolleg has developed into a very important think tank and incubator for interdisciplinary exchange and into a driver for novel interdisciplinary research projects that aim to address complex challenges of our time. Dear Mr. Enserink, I hope that the last weeks have been very pleasant for you and that you have been able to sense that the Comprehensive Research University is very lively and not just a phrase. Your program in the recent weeks has included seminars for graduate students as well as discussions with colleagues from a broad variety of disciplines, particularly the natural sciences, the life sciences, and mathematics. We are very grateful for your commitment and dedication. I will now hand over to Rafael, who will introduce the Klaus Tschira Foundation and subsequently introduce our guest speaker, Martin Enserink, in more detail. Thank you.
Thank you very much for those kind words, Professor Melchior. So I'm a professor at Purdue too, doing dark matters research. And 12 years ago or so, time flies, my colleagues are storming into my office. They go, Rafael, what's happening? And you know, one of them shoves the New York Times in my face. Neutrinos fly faster than the speed of light. You know, like, okay. No, of course not. But why does the New York Times title that? What had happened? So there's this experiment, opera experiment at the Gran Sasso Underground Laboratory in the Abruzzo Mountains in Italy. It's close to the experiment that I'm doing, so that's where the connection is coming from. And what they do is they measure neutrinos that they send from CERN to Italy, and they measure the speed of those as a side project, and they come up with a number, and it turns out, oh crap, the number of those neutrinos is faster than the speed of light. Of Of course, what happens is they naturally a lot of head scratching, right? And these collaborations, there's 150 people working on this experiment. They think and they cross-check and, you know, they check their statistical analyses and their hypotheses and whether they got the distance right measured by the geographers. And they check all those things and they couldn't come up with a solution to their riddle. And so they do what they have to do. They put a paper on the archive preprint server that says, look, here's what we've done, and if you take that as the truth, then it would mean that neutrinos fly faster than the speed of light, which is like super odd, so please help us in debugging this experiment. Well, that was the article, and I read the article, and there was nothing wrong with it, right? It was a collaboration of 150 people saying, look, we checked all this, and we couldn't find something wrong, please help us. Do you have a good idea of what could have gone wrong? So far, so good. Now, there's also a press release that accompanies that little article, and if you read that, it's already a little bit different, right? Well, scientists find, that neutrinos have a finding that would mean that neutrinos fly faster than the speed of light. But there's, of course, lots of doubts, and the community is asked to help cross-check. And then that gets to the newspapers, which have the big headlines, neutrinos fly faster than the speed of light. And in somewhere in the bottom line, maybe you know there's still some checks going on. And so what we see is that step by step, at every step in the communicating the science, it becomes more radical, more promising, more exciting, and more imprecise. Clearly, there are incentives inherent in the system that act the wrong way. And this is what I'm sure we're talking here today as well. This is what this is all about. For me, coming from the Klaus Tschira Foundation, I wonder, what can we do as a foundation to support the system to come out with the right outcome? Well, we can support non-profit science journalism because that's financially independent. We actually do that. We have the science media centers located in Köln. Their role is to provide experts to journalists that seek to report on new current science results. And so that's an intermediary between science and journalism. That's something we can do to help. Here's another possibility. We can have, together with Holtzbrinck Berlin, Anthony, it's great to have you here, we can have a Nature Marsilius guest professorship for science communication. We can try to stimulate those communications that we need to have as scientists, as journalists, as universities, as people working in academia, to figure out how to navigate the system and maybe how to come up with incentives. Martin, as part of this, has, as Professor Melchior has mentioned, given many seminars to students already. Most of them were full, some of them were oversubscribed and had lots of waiting lists. But if you have missed them, there's one more tomorrow at 9:30 a.m. Titled, Help, there's a journalist on the line, what do I do? So if you're a scientist and you want some guidance on that, I think there's still some spots left for that one. Fundamentally, science communication is about trust. If we trust someone, then we are open to new information. If we don't, we are not. And yet that trust must never become blind trust, one that overlooks weakness. And Martin is thinking a lot about exactly that issue. So it's my great pleasure to introduce you to our today's speaker. Martin Enserink studied biology at the University in Groningen in the Netherlands and decided to embark on a career in science journalism, and we can discuss on the spelling of that word. Since 1999, he works for the magazine Science, first at the headquarters in Washington, D.C., then as a correspondent and news editor in Paris, and eventually now he is moving through the ranks, deputy editor based in Amsterdam. Martin won numerous communication awards for stories on SARS, malaria, chronic fatigue syndrome. He won the Best American Science Writing Award for a story on golden rice. Actually, I remember that one. It's always good when one makes those connections. But he doesn't only focus on global health and infectious diseases. Martin also excitingly reports on research funding issues, on scientific misconduct, and yes, on research ethics. today's talk on exactly those importances of critical science journalism, titled Cheerleaders, Guides, or Watchdogs. Martin, I'm very glad to have you had here for those many weeks and over the season here at Heidelberg. Thank you very much. I very much look forward to your talk, to your plea for critical and independent science journalism, and what consequences we as a scientific community can draw for our everyday work. Please welcome with me Martin Enserink.
Well, thank you very much for these two kind introductions. And good evening, everybody, and welcome. And many thanks for the invitation to speak here. I'm very, very honored. My visiting professorship in Heidelberg started in early December, and it's now drawing to a close. I've had a terrific time. I've rediscovered that I really like teaching, and that's been wonderful. I very much appreciate the support for this visiting professorship from Holtzbrinck Berlin, from the Klaus Tschira Stiftung and the university. I'm also grateful to the entire team at the Marsilius College. Many of them are here, and I appreciate that. They have made me feel very welcome here in Heidelberg. They've also been very helpful in all kinds of ways. Special thanks to Tobias Just, who I think is the warm, beating heart of the entire college. Thank you, Tobias. This is a wonderful lecture hall. It's also rather intimidating. I think it was designed to make the speakers nervous, and that worked, actually. And in particular, this pulpit makes me feel a little bit like, it reminds me of the churches that I used to go to as a child, the Reformed churches in the Netherlands. But in a way, it's also kind of fitting, I guess, because what I'm going to tell you may sound a little bit like a sermon. I'm going to talk about sin, in this case, sins against science. So maybe it is appropriate, but I'm going to try to sound not too preachy about it. As you know, the visiting professorship is about science communication, and I practice one particular form of science communication, which is science journalism. And I sometimes call it the best job in the world. Well, you already heard a little bit during the introductions about my background, but I'll quickly go through it. I'm Dutch, and I obtained a master's degree at the University of Groningen. But I realized I would probably not be a great scientist. I did know that I could write, I knew that since high school, so I switched to journalism. I decided to become a journalist. And I wrote for a couple of news outlets in the Netherlands, starting with a little faculty newspaper that we made ourselves with a little club of friends. That's where I learned the first things about journalism, and then a few others. But as you also know, the Netherlands is a really, really tiny country, and I always had wanted to broaden my horizons. I wanted to live and work abroad. So that's how, in the end, I ended up at Science magazine, which I'm sure you've heard of. It's an American magazine, but it has a global audience. It's a weekly. It's published by a not-for-profit, the American Association for the Advancement of Science, and its headquarters are here in Washington, D.C., a few hundred meters from the White House. So that's where I moved in 1999. Then later I moved to Paris, France, and later again back to the Netherlands and to Amsterdam, where I'm based now. And I've had 5 or 6 different jobs at Science, sometimes 2 jobs at the same time. I'm currently the deputy news editor. I'm also currently on sabbatical, which is one reason why it was such a great timing to do this, visiting professorship. There's one thing I should probably explain about Science, because it creates some confusion sometimes. As you know, Science is a research journal, but it's really like 2 journals in one. It's a place where scientists publish their results with tables, graphics, findings, discussions, etc., the standard scientific articles. But it's also a news operation. It has the front of the magazine, the weekly print magazine, is news. And there are all kinds of stories about science itself, about science policy, about scandals in science, budgets, foreign news, anything that might interest members of the scientific community. And I work for this side, obviously I'm a journalist. And so a lot of what we do, they're stories that you might find in the Frankfurter Allgemeine Zeitung or maybe in the New York Times. They're journalistic stories, they're not science. And these two departments operate independently, so it's a bit like church and state. The editorial side doesn't tell us what we can write about, and we cannot tell them. We have nothing to do with what manuscripts get accepted or reviewed or published. That's their business. So that's why I'm calling it two magazines in one. And you'll see later on why this is important. Now, I've specialized actually in infectious diseases. Shortly after I arrived in Washington, somebody, and shortly after 9/11, somebody decided to send out a whole series of envelopes with anthrax spores to media and politicians, and I think also to the Supreme Court, all along the East Coast, which created a huge panic. A number of people got sick, some died. Of course, it was also a scientific challenge because anthrax is almost gone. Few people knew what it even was and how it made people sick. So I wrote lots of stories about that. And since then, as you probably also know, the field of infectious diseases has only gotten more, shall we say, interesting in several ways. In 2003, we had the SARS outbreak that started in China and then rapidly went around the world. We thought it might be a pandemic. It didn't become a pandemic because we managed to contain it. SARS was caused by a coronavirus. Well, I went to Beijing, among other places, to write about how China had handled the science, what they had done in terms of the scientific response. And actually, they really bungled it. That was the topic of the story. I'm just giving you a few examples of the work I've done. In 2014, we had another warning signal, if you will, from the coronavirus, this time in the Arabian Peninsula, where the Middle East respiratory syndrome virus suddenly erupted. And it was a virus that was transmitted through camels, so I went there to write about the science, the research going on into that disease and how it transmitted, which was in the beginning very unclear. And of course, 4 years ago, we had a third coronavirus, which you all know how that ended. That I did a lot of stories on that as well. But I've also done other types of stories. In 2016, I traveled to the occupied West Bank, and I spent a couple of days there with this young Palestinian scientist who had established a research center for neuroscience at Al-Quds University in the West Bank, under obviously very difficult circumstances. Really interesting, inspiring person. So I wrote a big profile story about him. Now, on the title of my talk, there's quite a bit of debate and discussion about the role of science journalists. Are we cheerleaders who love science, who encourage it from the sidelines, who celebrate its successes? Is that what we do? Or should you see us more as guides, as tour guides, as somebody who shows you around, who explains to the audience a world that they don't really know and they don't fully understand? Is our job to explain stuff? Or the third option, are we watchdogs? Are we primarily keeping a critical eye on science and exposing its weaknesses and flaws? Well, like I said, there's a lot of debate about it. I think we're usually a bit of each. You know, if you take the cheerleading, for instance, in 2015, I went to Guinea in West Africa during the terrible Ebola epidemic that struck that part of the world. And among other things, what you see here was a site where they were testing a new Ebola vaccine. The World Health Organization had organized this. It was a very unusual trial, also in the way it was set up, also very difficult, as you can imagine, in an Ebola country to do a study like that. But 3 months later, these researchers published the first interim data in the Lancet, and it was an incredible success. The vaccine worked very, very well. And so, of course, I wrote a story about that. Well, that was certainly something to be very happy about, to celebrate, maybe even to cheer for, because that was great news. And that vaccine has been used in other outbreaks since then, for instance, in the Democratic Republic of the Congo, and it's believed to have saved many lives. Now, the second role, the tour guide or the explainer, I think we do that very often. I think explaining, guiding readers is really a core business of many science writers, and we excel at it, I think, or many people do. We should be able to explain difficult concepts clearly in simple words. But I really mostly want to talk about the watchdog part. Because scientists are humans, and like people in any other profession, they make mistakes. Sometimes they behave badly. Things go wrong, and some science journalists like to focus on that. There are others who rather focus purely on the science and cover the scientific advances. But I think it's often interesting and important. And I see science journalism in a way not so different from, say, political journalism or sports journalism or business journalism. You also look at the controversies, the fights, the pettiness, the personal issues, and yes, the bad behavior. And at Science, we tend to do quite a few of these stories, and I want to give you a couple of examples. The last couple of years, of course, Me Too has become a big issue, and we've done a number of stories on that. This was a story by my colleague Meredith Wadman about a top scientist at Scripps in California who had been accused of sexual abuse over a period of several decades. She did a very long investigation and came up with this feature story, and the scientist later resigned. In 2013, we did a very nice profile of this scientist who was the director at the Max Planck Institute of Human Cognitive and Brain Sciences in Leipzig, and she studied empathy. And she was very much, she was into meditation herself, and what she was studying is whether meditation can make you a more compassionate person. So a really interesting field and an interesting scientist. So it was a nice profile, but unfortunately 5 years later, and in a very sad, ironic twist, the empathy researcher was accused of bullying and intimidating her colleagues and creating a very toxic work atmosphere. So, of course, we had to cover that as well, especially since we had done that nice profile. We felt we had to report this case as well. And it also made us wonder, should we have known when we published the profile? Should we have asked more people about what it was like to work in that lab? Another example that also affected Germany in this case, even Baden-Württemberg. This was a story by my colleague Rodrigo Perez Ortega, who's a journalist in Mexico actually, and it's about a rare dinosaur fossil that came to Germany in 1995. Illegally, you could say. It didn't comply with export rules from Brazil. It landed in the Staatliches Museum für Natuurkunde in Karlsruhe, not far away from here. And after Rodrigo started looking into this case, the government of Baden-Württemberg looked into it as well. They did an investigation and they said, yes, that fossil needs to go back. So we cover those issues as well. This is what some people will call scientific colonialism, and that is increasingly right now a topic we write about. But what I want to talk more about today is scientific misconduct, and classically that people have defined that as one of three things: fabrication of data, falsification, and plagiarism. And we've written a lot about these topics as well. People have asked me sometimes why focus on the negative, you know, why always expose all that dirt and those problems. Like I said, there are other science journalists who rather stay away from it. I find it interesting and fascinating because I think if you really look into it, it tells you a lot about how science works, how it operates, what its rules are. It's sometimes the psychology between people. I find that really interesting. And also, to be honest, it involves a lot of detective work, and I like doing that. I'm a fan of Scandinavian crime series. And I think misconduct is the closest in science that we get to crime, and it makes you a little bit of a detective. So I enjoy that. But I've also learned that these stories are not so welcome in the scientific community. Scientists tend to like it when we're the cheerleaders or the tour guides, but when we're the watchdogs, it can create problems. And even more so, I think, for the whistleblowers, the people who expose these cases, than for me as a journalist, because I'm not part of the academic community. And I want to introduce you to a few people that I've met and worked with who were whistleblowers and who had a pretty difficult time of it. These two people are Fredrik Jutveld and Josephine Sundin. They are two young Swedish scientists, and they, at some point in 2016, decided to blow the whistle. And it was something they'd never done before, they never expected to do, and honestly were not really prepared to do. They didn't know how to do it. Now, the paper they blew the whistle on was actually published in Science, in my own journal, but I already told you there's this church and state separation, so I wrote about it as if it had happened at another journal, and I think it's actually really great about science that we can do that. Now, this paper was written by two Swedish scientists as well from Uppsala University, and it was quite an alarming paper. It showed that, you know, microplastics, those tiny little plastic fragments that are all in the water and the oceans, that they have a really strong influence on young fish, on juvenile fish. These fish, they prefer to eat plankton over real food, the scientists found. They gobbled it up, and then it had very adverse effects on their behavior. It also made them more likely to become eaten by predators, which then in turn could have sort of knock-on ecological effects. So it was an alarming paper, and as often happens in such cases, it got a ton of press attention all around the world. I could have added 30 other stories in different languages that I found. But Fredrik and Josephine felt it was, they thought it was made up, that it was fabricated. The data were just completely made up out of thin air. And so together with 5 other scientists, they asked Uppsala University to investigate this case. Well, so what made them think that? Well, Josephine, who was here in Heidelberg last week at a seminar that I had organized about whistleblowing, then she told the entire story. I'm just going to give you a very, very condensed version of it, but just so you get an idea. Josephine had been, so the study took place at Gotland, which is an island in the Baltic Sea, at a research station there. And Josephine was there around the time when that study supposedly took place. And she also knew the first author of the science paper. On the right there, on the left is Josephine. They spent time together, they hang out like young scientists do at a station. And but Josephine was working on a different project, something she had her own study. She had also seen the first author of the science paper at work. She knew exactly what her whole setup looked like, what she was doing. This was part of that setup, and one of the things that Josephine said, this just wasn't right. When you read the science paper, this researcher needed at least 30 aquariums, but she only had this, so she logistically it couldn't have made sense, she said. And also, if you read the paper, the study would have had to last at least 3 weeks, even a little more. That was the time you needed to do all the experiments because there was exposure and then measurements, etc. But the first author was only at the island for 10 days maximum. So it just didn't. The timeline just didn't make sense. She said it couldn't have worked. It was impossible. I wrote several stories about this case, including this very long feature story, and I really delved into it. And I even went to Gotland to meet Josephine and Frederick, and that's where we took these photos. And I saw the lab where it all supposedly took place because I wanted to get a good idea of what had happened. And then, in fact, it did become a little bit of a Scandinavian thriller because. So Josephine and Frederick and these 5 other people, they asked the university to investigate. They gave them a whole list of things that they thought were wrong with the paper. Like I said, the timeline didn't work. They didn't have enough aquariums or beakers. They didn't have the number of fish. There were a whole list of 13 points that they said just couldn't be possible. So the university launched what's called a preliminary investigation. It didn't take very long, about 4 or 6 weeks, I think. And to the shock of the whistleblowers, the investigation said, no, these complaints are baseless, sorry. We've asked the authors about it, of the paper. All questions have been answered in a satisfactory, credible manner, and there's no evidence of research misconduct. In fact, they went a step further. They had some critical words for the whistleblowers. They said, you seem to have a very strong desire that this article is examined for research misconduct. But most of these issues that you brought up, you could just have discussed them as part of a normal scholarly discussion with the authors. In other words, they were berated for asking for an investigation. And also the authors of the science paper also were very critical and were angry. And they said these accusations stem from jealousy. You know, we have a paper in science, and now you're jealous, and that's why you're accusing us. For instance, one of them said, if you compare my CV with her CV, then it's a big difference. I've got a much better CV, so you can understand why somebody would be jealous about a paper in science. Well, Josephine last week in the session told us that she became very worried and afraid at this moment because the university had dismissed the allegations, had said you shouldn't have brought the allegations, and they were being attacked as jealous. And if that had been the end of the story, obviously it would have been very bad for the whistleblowers. It would not have been a good look. It wasn't the end of the story, however. I'm not going to give you the whole timeline because it's too long, but what happens, Sweden also has a national board for ethical, national research ethic boards, and the issue also went to that board at the request of the whistleblowers. And they reached a very different conclusion. They said they looked at all of the evidence and they said, yes, this was misconduct. And this was about 10 months after the paper was published in April 2017. And at that point, Science, which had already previously issued a so-called expression of concern, which means, we're not so sure about this paper. At this point, Science said, we're retracting it. The paper is gone. And like I said, church and state so had no involvement in that. I just wrote about it. At that point, the university, Uppsala University, said, okay, we'll do another investigation as well. We'll start again. We'll relaunch our own investigation with different people. It took about 7 months. By then it was December 2017, and yes, that investigation also concluded this was fraud, this was fabrication, these data were made up. And it turned out that the thing they'd said at the very beginning, there was never enough time for these studies, that proved the key argument. That alone was enough to say it's impossible that you did the study because when did you do it and where did you do it? So, in a way, this, you could say, all's well that ends well, and the whistleblowers were vindicated. But to me, it still left questions that I wanted to have answers to as a journalist. How come this preliminary investigation got it so wrong? Because it was, a tense, difficult time for the whistleblowers. And so I asked the university, and they never deigned to give me an answer. Just no comment. So we'll never know how that happens. But I also was curious, well, what about these whistleblowers? Do they deserve an apology or some gratitude? Did you thank them? So I called the rector and, oops, I see a typo there. The rector said, we have no procedures for thanking them. as if she needed some legal, official university academic procedure to say thank you for blowing the whistle, not thanking. So, so it made me realize, you know, this took them an enormous amount of time to put together these complaints, and they had zero gratitude. And it made me realize how difficult it is to be a whistleblower. And I've heard similar stories many times from many people, especially young people, vulnerable people who don't have a fixed position yet. Sometimes I've had to promise not to use their name when they told me their story, or not even mention anything they told me. They just want me to know. Sometimes I get anonymous emails from people saying you should look into this, but I can't tell you my name because I would be retaliated against. So there's a lot of anxiety, a lot of fear about that. And like I said, scientists don't always welcome whistleblowers. In another case that sort of partly overlapped with this fish paper, I asked one senior scientist what he thought about these accusations. Again, this was against another paper. And that scientist really was not amused. He said, you know, building a career judging what other people do is not right. And also, if such a controversy gets outside the community, it's harmful because the whole community loses credibility. So in other words, don't rock the boat, just do your own work. Don't put other people down, but just keep your head down and don't bring shame to our field, to our research field. That was basically the attitude. And I think if science treats young people who are trying to do the right thing this way, then it really has a problem. I want you to get to know another person who had a slightly different story. This is Ken Thompson, a young American biologist. And he published his first paper in 2014. And Ken later blew the whistle on his own paper. Now, how did that happen? Well, he had written a paper in 2014 with his supervisor, Stephen Newmaster of the University of Guelph in Canada. And they looked in the value of a technique called DNA fingerprinting. And in this case, they wanted to determine the species richness, how many plant species there were in a certain patch of forest in Canada. And they compared the traditional technique, which just means you look at all the plants, you write down the species and you count them, with DNA fingerprinting, which basically means you sample a ton of DNA from leaves and other stuff, and you put it all in a sequencer, and that tells you how many species there are. And the paper found that, yes, DNA fingerprinting is more precise, and it's also a little cheaper. But after the paper was published, Ken increasingly was concerned. He hadn't collected the data. His supervisor had given him the data and said, you analyze this, and then we'll write a paper together. But as he started looking into it, he had all kinds of issues. I won't go into the details, but there was a lot of fishiness in this paper. So Ken then did what he was supposed to do, and asked the university to investigate it, but he also asked the journal, Biodiversity and Conservation, to investigate it, and both took a long time, but essentially the answer was no. We've looked into this, it's not a case, we're not going to do a full investigation. And Ken got nowhere, but he got increasingly desperate, and so what he then did was publish a criticism of his own paper on Dropbox for everybody to download. Very nice, scientifically written paper. But he also published a blog post to explain what he'd done and why he'd done it, why he was disavowing his own very first paper. It's a big step for any scientist. And in that blog post he wrote, I don't want to deal with this alone anymore. I hope that by sharing a critique of our paper, some people will choose to support me here. And you know, if you let that sink in, I think it's a really sad comment on the state of science. If somebody is trying to do the right thing as a young scientist and is struggling with this alone and gets no support, it's a sad comment, I think. But this did get things moving, because for one thing, I wrote a story about the case, and he did find other people to support him, including at his own university. And they launched another, they asked again the university to investigate, which happened. And also the paper was retracted a couple of months after Ken went public with his complaints. So he got what he wanted, the investigation and the retraction of the paper. Now, it's often the case when somebody has committed fraud once that there's sometimes more in somebody's history. So one of our very good investigative reporters, Charles Piller, decided to look into the case further, and in particular into the supervisor and his career. And he spent a couple of months investigating the supervisor, who was really a big shot at the University of Guelph, had brought in tens of millions of dollars in research money, lots of high-profile papers, and so Charlie, as we call him, wrote a big feature story, and he basically concluded that the supervisor was charismatic, eloquent scientist, but he often exaggerated, fabulized his accomplishment, and presented other researchers' data as his own. And he had the receipts to show it. For example, this was one graphic that Newmaster had used in a talk. He said it showed unique signatures. We won't go into the chemistry, it's too complicated, but to identify coffee cultivars. So in this case, the DNA fingerprinting was used not to look at species, but specific cultivars in coffee. But actually that image had been used in a paper in 2012. It was not his own, it came from a Japanese research group who were also working on coffee, but it had nothing to do with the work of Stephen Newmaster. In another talk, he used this graphic, and he said this is data about cannabis identification, again using DNA fingerprinting. But the figure Charlie discovered actually came from a paper published by a different research group in 2012. It wasn't about cannabis, but it was about ginseng types, and so on. And also, Charlie started comparing things that Newmaster had written with other sources, and he discovered what looked to be like plagiarism. To the left you see what Newmaster wrote, to the right the text in original papers, and everything that's identical is in yellow. Well, there was a lot of it. So it was a pretty damning story, and I should add right away that Newmaster denied any accusation, and also said, I've never done anything unethical or never violated scientific integrity. Now, this university also, like I said, there was an investigation, and there was an investigation panel, and they said they looked into it, and they said, no, he's not guilty of misconduct. This panel only looked at 3 papers that the whistleblowers had flagged as fraudulent, including the one that was already retracted. The panel didn't look at all this evidence that Charlie had described in his science story, and they said in the end, yes, it was suspicious, it was poor judgment, but there's insufficient evidence for misconduct. So Stephen Newmaster is still at the University of Guelph. Well, now you might say, that's all bad and interesting, but at least nobody died, like in the Scandinavian crime series. But even that is not always true, sadly. You may have heard of this case. This was Paolo Macchiarini. He was a star scientist at the Karolinska Institute. They hired him because they really wanted to advance their work in surgery and combining surgery and stem cells. Macchiarini made artificial tracheas, windpipes, which he then seeded with stem cells. And he said, if you implant those, transplant them into patients, they grow back to an almost normal trachea that functions well. And he reported in the Lancet and other papers that these patients were doing well. Again, there was a group of whistleblowers who said, this is not true. These papers contain exaggerations of how these patients are doing. They're doing poorly, or some had even died. The Karolinska Institute hired an independent investigator to look at it. That person said, yes, this was misconduct, but then the vice-chancellor of the university effectively overruled him and said the independent investigator did not have all the information. If you look at the totality of the evidence, no, it's not misconduct. And that's where this case could have ended, with a no misconduct finding. If it hadn't been for this Swedish television journalist, Bosse Lindqvist, who also looked into the case and who investigated for a long time, he had a lot of footage. He made a documentary, 3 parts, called Experimenten. It was aired on Swedish TV in early 2016. And if you haven't seen it, you should try to catch it at some point, because it's fascinating, and it's really also chilling piece of journalism, I think. He later also wrote a book about the case, and this caused so much consternation in Sweden that all of a sudden the case was blown wide open again. And Karolinska said, okay, we'll look at it again. Then they fired him. A lot of heads rolled of prominent people. It became really the biggest, the worst crisis in Swedish science in a long time, maybe ever. And papers were finally retracted at that point as well. And it did literally become a crime drama, because Macchiarini was also prosecuted for what he did to these patients who received a trachea and who did so poorly. And last year he was sentenced to prison for gross assault on 3 patients. So misconduct can have very serious consequences, is my point. And I find it scary to contemplate that if it hadn't been for Bosse Lindqvist, this journalist, that this case might have simply have died, and justice this would not have been done. Now, you're probably going to ask me, well, but Martin, how bad is it really in science, and is it getting worse? You would think so if you look at just at the number of retractions over the years, which the site Retraction Watch, which you may have heard about, does a terrific job of keeping score and keeping track of every retraction in the literature, and also has a big database which people now do actual research on, and so they can show trends and do studies. But as a percentage of the number of papers that actually gets published, the number of retractions has increased about 4-fold since 2002. Now, it's tempting to think that means there's a lot more bad behavior in science. I don't think that's entirely the case. There's also more interest in misconduct, and there's more vigilance. For example, perhaps you've also heard of Elizabeth Bik. She is a scientist. She's actually Dutch, but she lives in the Bay Area in California, and she has an incredible eye for spotting image manipulation and duplications. You know, of this type, where two different gel bands are supposedly from different experiments, but in reality they are the exact same band. Now, sometimes this can be the result of an inadvertent error that happens, but often it is not. Or sometimes they appear to be manipulated a little bit so that they don't look the same, and it's just reusing and reusing and reusing the same image. So this alone, I mean, Bik has exposed hundreds and hundreds of these cases, which he puts on PubPeer, a website where scientists can post reviews of already printed papers. Now, that alone has led to many retractions. And there are other things that, which I won't get into now, that mean that retractions happen more often, but don't necessarily reflect a rise in the incidence of fraud. But I do think, here's one other data point. So there's a group of Dutch researchers who did a survey back in 2022 among about 7,000 scientists, and they basically asked them, have you ever done anything wrong? And 8% admitted, confessed that they had fabricated or falsified data. Of course, this was an anonymous questionnaire, which is 1 in 12, which I think is a lot. There haven't been many studies like this. Others have found a lower percentage. A lot depends on exactly how you ask the question. But these researchers think 8% could actually be an underestimate. That's also what I believe Elizabeth Bik thinks. And unless you assume that we as Dutch people are particularly dishonest, there's no reason to think that the same wouldn't be true in Germany or any other country, I think. Okay, I'm nearing the end of my sermon. There's just 2 more things I wanted to address. One is obvious. What can we do to improve the situation? Well, a lot of people have been thinking about that, and there's an active discussion about it. And some of the ideas that have been discussed are, of course, change the whole incentive structure, make it so that young scientists don't have this tremendous pressure to publish fast and in high-profile journals, put more emphasis on rigorous science and reproducible science. That will reduce the pressure to cook up data. Improve the peer review system so that these bad papers are caught before they get published, and that as a result could also lead people to submit fewer papers with made-up data. Make the investigations truly independent, because as I showed, it's often the universities who have to investigate their own researchers. That's sort of the standard procedure, actually, also here in Germany, I believe. And that creates an inherent conflict of interest, because no university likes to have misconduct in their house, especially not if it's a high-profile researcher. It's painful for everybody. You may lose a lot of money. It creates problems. So there's an inbuilt conflict of interest, and I think it would be good if those investigations could be more independent. And finally, support the whistleblowers, because as I showed you, they don't get a lot of gratitude, even though they have sometimes spend a long time working on a case. They take risks. For instance, you could give them, you could compensate them for the time that they missed working on their own project, and say, okay, you spent 4 months on this. Well, we'll give you funding to continue your own research for 4 extra months, something like that. But also, yeah, I think they deserve an award. I mean that literally. We have thousands of scientific prizes. Wouldn't it be nice if there was one for responsible, conscientious whistleblowing, to show that science has a commitment to research integrity? And the last point I wanted to make, some people ask me, aren't you worried that writing about all this stuff, about the dark side of science, will only further erode the trust in science? And my answer is yes, I do worry about that. We're living in a time when trust in science is on the decline. There's a tremendous amount of misinformation, disinformation, all kinds of conspiracy theories. 2 of my predecessors here in the Nature Marsilius visiting professorship, Eva Wolfangel and Michele Cantazzaro, have talked about this in their lectures about possible solutions, but I don't think we really have the solutions yet, neither scientists or science journalists, about how we fight this tsunami of misinformation and disinformation. But I think certainly looking away from the problems in science is not the solution. I think, on the contrary, I think scientists should be more transparent about how they work. The public should have a better understanding of how science operates. That science has a lot of uncertainty, doesn't always know the answers. Sometimes that get lost as well. And also, yes, being more forthcoming in exposing the problems and the weaknesses. And that's why I hope that, independent, critical science journalists will also keep writing these stories, even about misconduct, because if we don't do it, I'm not sure who will. Thank you very much for your attention.